Hi everyone, Carly Cryle here, and I just want to share with you guys my teaching strategy project. I had physical science for the 5th grade, and I also had simulations. So my strands that I picked, of course, physical science, topic, light, sound, and motion. The content statement was light and sounds are forms of energy that behave in predictable ways. So mostly I focused on sound, particularly in this lesson, um, but students will explore and learn this statement through guided instruction and online simulations. Okay, so the main question that the students will focus on is, does sound waves behave in predictable ways? We're relating it back to the standard, in predictable ways. And explain your reasoning using the simulations to support your answer. Okay, materials that students will need to complete this lesson. They will need their Chromebooks, interactive science journals to write down any questions that they have, write down any of their answers or their findings that they had, any explanations they'll have to write down, any charts or graphs that they found interesting while completing the simulation. They'll have to have a pencil, of course. And since we are dealing with sounds on the simulations, they will need their headphones. Okay, so step one of the activity. Step one, we would just be showing them a video before we get started on the simulation, just kind of to ease them into the topic. On the standards, the Ohio State Standards website, I kind of found this interesting source. I didn't even think about it. It was PBS Kids, and they have a learning media website, not just PBS like the movies and TV shows that you can get, but they also have a lot of good information. So this video that I would show them before the simulation came from PBS. Students will be shown the activity question on previous slide though. They will form their hypothesis before gathering information. So before they start, they'll read the question, does sound waves behave in a predictable way? And they will make a hypothesis. And this is before watching the video as well. And then now, as a class on the smartboard, we would watch the short video from PBS. Um, right here is the link. There we go. And here is the video. I do not know if the screen recorder actually catches the video sound, but it's just as you can see, a short little minute, 30-second video. And then they would watch that. After students watch that, they will write down any questions they have. And then at their group tables, they will do a think, pair, and share. So they will ask their friends their questions or their table mates, see if their table mates have any of the answers, and then we will continue in a classroom discussion to follow up on any of those unsolved questions. So now after the video, step two, as I said, class discussion on students' questions. Then I will ask them some more critical thinking points after we have more answers and more solving. What were some things that stayed consistent, stays the same when sounds happened? How can you tell the difference between loud sounds or quiet sounds? In the video that they watch from PBS, it discusses that a little bit, and then later on in the simulation, they'll have the opportunity to perform that themselves. And then what happens when you push on a drum harder or softer? And again, the PBS video does elaborate on that. I don't think the sound does work when we do the screencast thing on the computers, but I highly encourage you guys to go to that link and watch it. It is very informative. And step three, students will write down some of their thoughts, ideas, and answers in an interactive notebook. So anything that caught their eyes, any of the questions that they were like, "Ooh, I need to write this down to remember," they can write it down in their notebooks. Students will focus on simulations shown on the board. So first, before I let them just go on their Chromebooks and do it themselves, I would like to show them how to get on the website, what settings to go on. That way they have a little bit of closure on what they're doing. After understanding how to control the simulation, students will be able to experiment on their own. And then the link is right here for the simulation. There we go. So like we've done in class, this is the same website. They'll just have to push play and it'll load. And then I'll have them push waves. And then we're going to change it. Right now it's on the water, but I will have them change it to the music, the speaker. And I want them to push play tones and graph. That way they can just get a little bit more out of it. The students can just play around. It does give off a sound. They can change the frequency, the amplitude, and while they're doing this, I want them to remember what we are focusing on. Right now, we're focusing on seeing if the sound waves is predictable. Will it stay the same? Like if we put high amplitude, will it always stay the same frequency? Can they predict what the waves will do? So that's what they're focusing on. So that would allow them, I don't know, 20 minutes of free time or just reading on the class, seeing how interested they are, maybe not quite 20 minutes. Some kids would probably be able to look at it all day, and some kids would just be like, no thank you, I'm done after 5 minutes. So just really reading into your class, seeing what their attention span is. So after they have a little bit of time, I would rein them back in, and then step 4 would be explaining the stimulation. So students will enter a link and push play, and this is kind of what I was explaining earlier. They will push on the green waves on the graph to the right to change it to the speaker option, waves, playtone, and graph, explore options, and then after investigating, they will write down observations to help them to decide if the waves are acting in predictable ways. And as we know, yes, they are. And then they will make a chart of their finding in their notebooks. Okay, step 5. At the end, students will be able to conclude and answer these questions. Are sounds predictable? Yes. Do frequency and amplitude affect the sounds? Explain how or how not. And what forms of energy was causing the sounds? Give example from the video or simulations. So that was my teaching strategy project. I hope you were all able to learn and gain something from it. I had a lot of fun making it. And yep, thank you guys. See you later. Bye.